Welcome back. Today is day 4 of our right triangles unit. We will be learning about the Pythagorean theorem. Hope you enjoyed the video. Alright, so what do we notice after you watch this video? It's a great video, and it basically shows you exactly what the Pythagorean theorem is. So in this video, we should notice that there is, you should see that there's one yellow triangle. So there's one yellow triangle, and that's very important that you notice that. So there's one yellow triangle, but a lot of students don't notice this also. So behind the little YouTube sign, there's a little square. So we know this is a right triangle, and that's important because our Pythagorean theorem only works when we have a right triangle. So we're going to need to know that for as we go. But what was the other thing we noticed? Well, we noticed there were some squares, so they put squares on the sides of your right triangle. So we noticed there was 3 squares. All right, so what happened in this problem? Describe what happened. Well, they rotate the model there, and the water from the 2 squares fills up the big squares and vice versa. So water from 2 squares fill the larger square. Okay, sorry, so messy. But that's basically the whole point here. So what relationship is this trying to show? What we should notice is that the area that is created, so there's 2 squares here. So these 2 squares, they have the same exact area as this larger square. So because they filled it up perfectly. So hopefully you notice that it filled up this larger square perfectly, and it did it both ways. So the 2 smaller squares filled up the larger squares. So that's what we're talking about. And really, in this image, we're trying to show that the area of these 2 small squares fills this up. All right, so that's what we're trying to see. Summarize this in terms of what is the Pythagorean theorem. So it says the sum of the squares on the legs of the right triangle is equal to the square on the hypotenuse. So when we add together these 2 squares, and what we should know is that this area will be b squared. And let's see if that makes sense. This has an area of b squared. And think about that. Because one side's b, the other side is also b, it's a square, and b times b is b squared. And if we look at the other triangle, this other square, this has an area of a squared because it's going to be a times a, which is a squared. So what we notice is that the sum of these two squares, so a squared plus the b squared, we know that those 2 will fill up, so they have to equal the larger square. And what's the largest square? Well, this is c, each side is c, so c times c, which is c squared. So this is our Pythagorean theorem. This is what we're learning today. So the area of the 2 smaller squares has to equal the area of the larger squares. All right, perfect. A couple things I want to write down. What we should notice in this problem, C is the hypotenuse. And I notice it's always, when I look for it, I look for my 90-degree angle, and I notice that it's always across from the 90-degree angle, okay? And the other 2 sides, I'm going to write those ones, A and B, they are legs. So we call them the legs, okay? So, and what we notice about A and B is A and B, if I write those in there, they're next to the 90. So the parts that are next to the 90 are adjacent to the 90 degree. The sides that are adjacent to the 90 degree are the legs. Okay, so we'll refer to these as legs as we're going on to other problems. But that's the Pythagorean theorem. Hope that makes sense. Let's solve this problem. It says find the missing side of each triangle. So you see we have 2 sides of a triangle, but we're missing one. We don't know the 3rd side. But we're going to use the Pythagorean theorem because this is a right triangle. And if we notice it's a right triangle, then we can draw the squares on the sides and we can use that to help us solve this problem. So we'll do it the long way for a couple times, but then after that, I'll do my best to draw squares. So that's I did my best to draw those squares. All right, so what we said that there's a formula here, a squared plus b squared is equal to c squared. So the area of the two smaller squares has to equal the area of the third square. So let's go ahead and solve this. Let's see if we can figure this out. So what is the area of the smallest square? Well, it's 3 by 3. So this must have an area of 9. So I'm going to write this down over here. So this is 3 squared, which is going to be 9. I'll write that in right there. The next square is going to have an area of 16 because that's 4 by 4. So this has an area of 16. So that's going to be, this is how you would usually do it. Just plug in a 4 and you would get 16. Perfect. And equals, and I'm going to do it this way right now. So what's the area of the largest square? Well, the side's x, so the other side must be x also. So this must have an area of x squared. Does that make sense? You have x times x is x squared. So guess what? This area is going to be x squared. So here is your problem that somewhat worked out. It's almost already done. So we found the area of each square. So one square was 9, the other square was 16, and the area of the largest square is just going to be x squared. We're going to find that right now. So now watch what happens. This is 25, and this gives me x squared. So what we're saying is that the area of that large square must be 25 because 9 plus 16 should fill that up. All right, for thinking back to the demo. But now we're going to go back to our mathematics, and how do we find our side length? Well, we would take the square root, and that will undo your radical and your square. So that'll leave you with x is equal to the square root of 25, which is 5. And there we go. So how long is this side? It's going to be 5. And does that make sense? Yeah, of course. 5 times 5 is 25. That's what we said the area has to be. So that's what you're going to be doing. You don't need to draw the picture every time, but you can do it to start, but you should just be able to use your algebra to solve the problem. So let's try the next problem. So in the next problem, I'll do one more with the pictures. So here we go. Let's sketch out my same problem. Let me draw the squares on the side of this right triangle. And remember, it only works for the right triangle, so it has to be a right triangle. So let's go ahead and write this out. So we know a squared plus b squared is equal to c squared. And here's what we know right now. Let's go ahead and find these areas, all of them. This side has a side of 10, so 10 squared would be 100. So this has an area of 100. 8 times 8 is 64, so this has an area of 64. And x times x is x squared, so this has an area of x squared. Now, we should be able to see where those go. This is going to go nicely, so this will be, and remember, the two smaller squares will add up to the large square. So the two sides on the legs, so this should look like this. X squared plus 64 is equal to 100. And now something's going to be different this time. Well, x is on the other side of the equation this time, which means we're going to have to do a little bit of solving here. So I'm going to subtract 64 from both sides of my equation. That shouldn't be too bad. So you're going to be left with x squared is equal to 36. And does that make sense? Yeah. 36 plus 64 is going to be 100. And now you can solve it like normal. Just take the square root of both sides and you'll be done with this problem. So you'll get x is equal to 6. So that's how long my side length is. So this side over here is going to be 6. All right, so that's how you're going to use Pythagorean theorem to solve this problem. So I'll try a couple more for you real quick. And then we will move on. So let's try, here's 3. So again, I'm going to try this one with no squares. I'm not even going to draw the squares. So I'm just going to write the formula. A squared plus b squared equals c squared. So I could draw the squares if I wanted to, but I'm not going to do that. I'm just going to label these. So I'll call these a and b. So here's a, here's b, and here's c. And now I'll just substitute in. So I'm going to have x squared plus 12 squared is equal to 13 squared. Now remember, C is always the hypotenuse, so make sure you're paying attention. Where is C at? And it's always across from the 90-degree angle. And after that, there should be no problem. So we'll get x squared plus 144 is equal to, and again, you can throw this in GeoGebra and solve it if you like. It'll do it for you, no problem. So x squared is equal to 25. I just subtracted 144 from both sides, and now I'm going to take the square root. So the square root is going to leave us with x is equal to 5. And we are done with this one. So x equals 5. All right, perfect. And we'll do one more, and then we'll call it a day. So on the last problem, let's look at the last problem. Find the missing side of a triangle, leave your answer in simplest radical form. So a lot of times we just want to leave the answer. We don't want to use a calculator. We don't want to take this to a decimal. We just leave it with a radical and simplify the radical if possible. So let's go ahead. I'm going to label my sides again. Here's my legs, so I'll call those A and B. And remember, C is across from the 90, so there's C. And we know our formula is going to be a squared plus b squared equals c squared. Quickly, we can write in our values. So we have x squared plus 8 squared equals 9 squared. And find the areas of the squares now. Oop. Let's change that back to x squared plus 64 is equal to 81. This is good mental math. Helps you with your solving there. So subtract 64 from both sides, so x will be equal to 17, x squared, sorry. Then take the square root of both sides and you're done. So my answer for this problem is x is equal to the square root of 17. Now I know 17 is prime, so I know I cannot simplify that any further. So how long is this side? The square root of 17. And sometimes we just want answers that way. So sometimes we like it better. It helps us see patterns. You'll see shortly that it's nice to simplify and not to use a decimal value. All right, hope you enjoyed this lesson.